So if you clicked on this video, that means you are interested in data science, artificial intelligence, and machine learning. Well, you've come to the right place. I'll be going over what data science even is and what a data science role will entail and what to expect when you are actually in this role in industry. I'm essentially a machine learning engineer by day and a data scientist at night, as I always like to say. So I am a consultant at a very large consulting firm, and I've dabbled a lot into the implementation side of things on how to stand up a model, how to deploy it, how to maintain that model, how to train the model, feed it a variety of inputs. I dabbled in natural language processing, convolutional neural networks, you name it. So I'm here to shed some light on what a data scientist is expected to be doing at that particular role. I could be breaking it down step by step on what to expect. Hello, beautiful people. Welcome back to my channel where I talk about all things tech and finance. And if you are new to this channel, make sure you hit that subscribe button and hit that like button. I really appreciate that. So data science, artificial intelligence, machine learning, they're all in general used to refer to the same thing in, colloquial speak, but this is actually not the case. Data science is an umbrella term that encompasses what AI and machine learning is. Machine learning is a subset of AI, and AI is a very loose definition in what machine intelligence is. It's essentially trying to find a pattern to solve a particular problem, where machine learning is actually the definition for a very, very specific algorithm to find that said pattern. There are three main categories of the data science world that you should be aware of. First, there's the original data science position, then there is a data analyst, and then there's a data engineer. A data science role is someone who goes in and actually develops that statistical or machine learning model. They're the ones who are like hypertuning and trying to find the various ways in order to find that perfect model to get that really, really nice result. A data analyst is slightly different from that of a data scientist. A data analyst runs SQL queries to, get their data, and then they use this data to generate some spectacular visualizations to help communicate where their client is or what specific phase their client is at and where they need to be. They help be the bridge between the data world and the client in order to formulate a business proposal. A data engineer is essentially the backbone of the entire data world. They're the ones who create data pipelines to feed into databases. They also help out with data scientists and data analysts to make sure that the data that each of these roles are using is clean, concise, verified, featured, and has a very nice dictionary with metadata features that are associated with each of these tables. They also help with deploying a machine learning model. So their value is very, very underrated. So you hear the term data being thrown around, but what exactly is data? Well, data is actually everything, but not really anything. So data can refer to images. It can also refer to free text like PDF documents, Word documents. It can also refer to your typical tabular format where you have records upon records of observations that are stacked neatly into a matrix format. But you want to make sure that your data is in a standardized format. And what I mean by a standardized format, so let's say you're working with image data. You want to make sure that the dimensions of the picture, in this case, are the exact same as the following picture, and then so on and so forth, so that you can feed this data into your machine learning model without any issues. Sometimes your images have different pixelated length. Sometimes they have different dimensions. They have length, width, or they have length, width, and height. So you do want to make sure that you take that into consideration when you are utilizing such data sources. The same can be said with text data or tabular data. Text data needs to be from the same relevant source, talking about the same subject material that you are trying to model. And if you're working with tabular data, you want to make sure that that specific spreadsheet has all the corresponding features that are always being calculated and no additional features are being added to that specific data unless you want to start joining on some specific feature that you have going on. From this point on, I'll be referring to data as a tabular data set format in order to just be consistent with my terminology and explanations. So I'm going to go over the overall stack of what to expect when you are inside the data world. The first thing that you should be expecting when you're in the data science world is that you have to identify a business problem and whether or not that particular business problem is actionable with a variety of data sources. Once you have identified your particular business problem, the next step is that you have to identify the variety of data sources in order to address this particular problem. Now, this can actually be really easy or pretty tough, like really difficult. The easy part is like if you are working with a client, let's say the client's pretty developed, they have an entire infrastructure set forth and they have data stored in a variety of data warehouses. The only tricky part is to try to find a way to concatenate or combine your variety of tables together to get the one large data set that you're looking for with all of the appropriate variables for your machine learning algorithm. The hard part is that if you don't have any data, you have to figure out a way to get that data. So if you were to try and scrape it from, let's say, like some website, that can actually become a little bit tricky because you have to read the terms of service. You have to figure out whether or not using a third party's data is actually commercializable. And you have to figure out whether or not that data is actually reliable to your particular use case. More often than not, if you are at that stage where you don't have enough data to work with, you probably have other issues that need to resolve first. That being, you have to develop an infrastructure to start collecting your own data, start storing it in some infrastructure, some warehouse environments, and then you can worry about the machine learning, the data science aspect of it all. And if you thought about potentially purchasing your data from some third-party website, that can actually become really expensive. Sure, you can develop some form of partnership, but over the long term, if you want to develop some form of strategic advantage, I would recommend that that particular company or you were to develop an infrastructure that were to collect that data that you are looking for. So assuming that you have your data sets at the ready, the next step is that you have to do a variety of feature engineering techniques in order to clean your data. And so this is where the bulk of your time will actually be spent because just cleaning your data takes so much time. So expect to spend like maybe 70 to 80% of your time just cleaning data. And what I mean by cleaning data is that you have to identify your most important features. You have to identify whether or not you want to impute missing values or remove potential duplicates, what you can be doing with NAs or null values. You have to determine whether or not that particular feature even adds any value to your overall model. And then you would have to go back and forth from the modeling aspect to your feature engineering aspect to try to make it so that whenever you are hyper-tuning for a specific results, you want to make sure that the data that's being fed in is as clean as possible. And so there's a very old term saying in the data science world, it's going to be garbage in, garbage out. Of course, we don't want to feed very messy, bad data into your model because you are then going to get very bad results. So assuming that you have a very neat and clean looking data set, you can then go to your next step, and that is where the modeling aspect comes into play. And so this is where the term of predictions is really, really exciting. This is where the buzzwords can be thrown around. But yeah, this is where all of the modeling happens. You're given some form of clean data set, whether it be a classification problem or a regression type problem. You can then utilize this data to generate a variety of predictions. And then you want to hyper-tune and minimize your whatever you're trying to minimize. So whether it be errors or you want to maximize your accuracy scores or get a very desirable F1 score or a desirable P score or a P value, should I say. So that is where a lot of fun happens, and it sort of becomes like an art form, especially when you're working with like neural networks because it's such a black box algorithm. This is also where you come into the hardware space. So when you are trying to train an algorithm, more often than not, when you're working with millions, potentially even billions or even trillions of records to train your particular algorithm, your model, you have to work with some very large supercomputers, and this is where you can find a difference between CPUs and GPUs and how much of a GPU is so much better than a CPU when it comes to massive amounts of data. So assuming that you have generated a very functional model with a very high accuracy score or very low errors associated with that model, the final step is where you can finally deploy and maintain that particular model. Although this is more of a machine learning operations role or a software engineering role, a data scientist should actually be very much aware of this process, because more often than not you might be aiding in this process when you are working with, just trying to figure out how to deploy your given model. This is where you definitely get into the cloud services type area where you're working with either AWS, Azure, Google Cloud, you name it. You can be working with message brokers such as Kafka or RabbitMQ as an intermediary for your Dockerized services, using Docker and then Kubernetes as a result. And then you want to make sure everything's going to be functional so that it can talk to the front end, where that front end could be a dashboard using Tableau, Power BI, or even Flask, some form of front end service. And in order for this to be interactable with the client or maybe even some customer in the entire World Wide Web. So yeah, just based on my personal experience, you actually won't have, all of these roles like typically filled. You won't really have, one person doing, the deployments. You won't have one person doing specifically the modeling development. It's sort of like an integrated role that you can be going through. So it's definitely eye-opening, and you're going to be learning a ton if you are going to go through this role. So yeah, that is essentially what a data scientist will go through and what you should be expecting to do if you are going to be pursuing the data science role. If you have any questions, please let me know down in the comments down below. If you like what you saw, make sure you hit that like button and subscribe. Turn those notifications on for future content. And thank you guys so much for watching, and I hope to see you in my next video.